So we're now going to look at the answer that we've got to our previous warm-up question in a bit more detail and see if we can see what this answer is telling us. We've got a negative number. Now, often, but near enough all the time, the minus sign on the force tells us something about the direction. Now, if we think about where we drew the diagram of the problem here initially, we've taken anything to be positive to be going towards the centre of the circle. So in this case, we said t plus mg is positive, and that's going towards the centre of the circle. At the bottom, we said positive was towards the centre of the circle as well. This is a common feature of circular motion problems. So we're saying the positive is going towards the centre. Now, the fact here we've got a negative tension is telling us here that at this point, at this top point, the tension would have to be acting away from the centre of the circle. Now, that is all for this condition to be met. When we apply our formula for force in minus force out, that is effectively the condition for circular motion to happen. So this is our condition for circ motion for this case. Now, we cannot have a negative tension in this example, because that would require the string to actually, or whatever you were attaching the bung with, to have to push outwards on the mass at this point. We know that that's not possible. So this negative tension here is actually impossible. It cannot be the case at the top of this loop that the tension is negative, because that would mean the mass would have to be pushed out by the string, and we just know that that cannot be done. So what does that mean? It means that this condition, by applying this force in minus force out, is not being met. And what does that mean? It means that at the top of this loop, or as the bung gets to the top of this loop, it is no longer in circular motion. So instead of the bung going and completing the whole loop, you would find, in fact, that the tension became slack and it fell down and completed a loop with a lesser radius. So just to recap, the significance of that minus sign is telling you that for circular motion to occur, that tension would have to be pushing out from the circle. We know that that isn't possible, but you do have to consider, based on the situation, whether that could be possible. For string with tension in it, it won't be possible, but for other situations it might be. And because that's impossible, it means that this condition is no longer going to be met. And we said on Thursday our key thing is force in minus force out must equal mv squared over r, or m r omega squared. And what this can be thought of is this equation, this equality here, has to be met for circular motion to happen. So this can be thought of now, rather than just a formula that you have to remember. It is a condition, a necessary condition, for circular motion to happen. If this equality is not being met, then we're going to be in a position where the object is no longer in circular motion. Just like the tension, just like this situation where the bung would not actually fully complete this circle, but rather fall short of completing it. This is what you're more likely to be asked about in the more difficult questions, the sort of grade A star even questions. For the lower level questions or the more straightforward questions, you should be able to work these. You should be able to work these numbers out and then to give you sensible answers. But what I'm trying to show you here is a technique when you see something going wrong like that, and that's telling you that this condition is no longer being met. In the next video, we're going to have a look at a situation where we look at this as a condition in more detail.